Yeah, you are all welcome. Let's go. Let's go to the class. Let's go to the class. We are going to the class to teach mathematics, indices. I'm here to assist the students. This is what I can do. You know, God has given us wisdom, and the only offer I can give to them is to teach them mathematics free. Leave the road. To teach them mathematics free. Not only just that, I also encourage them if I ask questions and any one of them respond very well. I encourage them by giving them writing materials, biro, books, and the rest. So distance is not a barrier. If you want to support this career, you can reach out to me, you DM me. Right now, we are going to the class. It's a boarding school. It's a boarding school, government college. We are going to the class right now. This is what we can do to assist the society. You know, in Africa, when once you're a lecturer, we forget about our roots, most especially secondary school and primary schools. In advanced countries, you see that professors will go down to go and teach in primary and secondary. I want to set the record straight that it is not true. We can also do that. So we are going to the class right now. We are going to the class. The class contains SS1, SS2. I teach advanced mathematics. We are going to the class that will make them to answer JAMB questions, WAEC, NECO, and look at them. Look at the students here. They are very brilliant. I've been coming here to teach them. Please sit down, sit down. This is the Govt college. Kurmin-Mashi, Govt, Kaduna. Yeah. So last week I was here. Last week Friday, I was here. We did a lot of mathematics on logarithms. Two of us. Yeah. Today I'm here again. We are going to look at indices. Is that clear? Yeah. So let's start. I'm very sorry for coming late. You know, our society, we have a lot of excuses. If you know that if you don't have a right, you know, we follow public transport. Conductor and the rest delay, driver delay. So I want to apologize that you should forgive me for coming late. Next class, I will not come late. Okay, so let's look at, I think you are able to solve this problem, right? Yes. Yes, okay. So I will look at it later. This is last week's problem. This week we want to talk about indices. Amen? Okay. Today is what? 31st October 10th, 2025. Right? Okay. Copy. indices. Indices. Then we'll be talking about laws of indices. Laws of indices, all right? Which I know that you'll be taught, two of us, which I know that you'll be taught. But the indices I want to do this morning is more advanced. Amen? Amen. That will make you to solve WAEC, NECO, JAMB. Also will prepare you to year 1, ND, and so on. Is that clear? So, before we go deep, in indices, we have laws that are guiding indices. Is that clear? Just like logarithmics. Amen? Just like logarithmics. So, we are going to look at laws of what? Indices. Amen? Okay. One of the laws is multiplication law. Is that clear? One, no noise. Please stop making noise. Multiplication law. Multiplication law. Yeah. Multiplication law says that if the bases are the same, you add what? The powers. Is that clear? Please stop talking, listen. Is that clear? Yes. Okay. So now, before we proceed to consider multiplication law, when we have something of this form, you don't need a prophet to tell you. It is in index form. So if we have this, we call this base. Is that clear? Yes. Then we call this power or index. Or index, right? It's okay. We call this power or index. Amen? Amen. Okay. So when we have this, it means this is base and this is what? Power or index. So let us look at multiplication law this morning. How this will be applied in multiplication. So if now we have a raised to the powers of x times a raised to the powers of y, you know that this is multiplication law. True or false? True. What makes it multiplication law is because of the operation here. What is here? Times, right? Yes. So, for the fact that this is multiplication law and the bases are what? The same. True or false? Yes. We have A here, we also have what? A. So you pick one of the bases, then raise it to the powers, you add the powers. Is that clear? Yes. So it means this is equals to A raised to the powers of x plus y. This is the answer. Is that clear? Yes. You cannot add this and this. Do you understand? Yes. I know some of you want to add it in this form, x, y, which is wrong. Please take note. The reason why you cannot add, this is x, this is y. Yes. So you cannot add it, just like if you want to cook. You are using stove. Can you add kerosene? Or can you add water into kerosene, then put it inside stove and cook? No, it cannot work. True or false? It means it cannot give you the flame. True or false? So that is how it is. You cannot add this and this to give you x1. Is that clear? Take note. So you leave it like this. Are you following? Yes, sir. Are you following? Yes, sir. Is that clear? Yes, sir. Okay. So now, in JAMB, WAEC, or NECO, or when you go to tertiary institution, sometimes you may not notice this sign here. Sometimes they might present it in this form: A raised to power X, then Y raised to power F, A raised to power what? Y. When you come across something like this, to simplify, it's the same approach. Is that clear? Yes. It means this one is multiplying this. This base is multiplying this, two of us. So what you need to do is you apply the same, since the bases are the same, right? Yes. So you apply the same approach to say A raised to the power of X plus what? Y. But sometimes you may see it in this form: A raised to the power X dot A raised to the power of Y. Most especially further mathematics make use of this dot. Dot is the same thing as what? Times. Take note. Is that clear? Yes. So in case anywhere you come across something like this, you are still going to use or apply what? Multiplication law. Are you following? Yes. Do you understand? Yes. It's okay. So if you understand, it means this is the same thing as A raised to the power of X plus what? Y. So that is multiplication law. No. Take note. Is that clear? Yes. Are you following? Yes. Please take note. Then, let's consider division law, right? Division law, right? When we say division, that is, you are dividing two things, two of us. Division can be represented, we can use this notation, this or this, two of us. Two of us. Please look up. This class will help you grow mathematically. Is that clear? So please be serious. So this is the same thing as what? Division, right? Yeah. So it means when we have A raised to power X all over A raised to power Y, or A raised to power X divides A raised to power Y. This implies that since the bases are what? The same, right? So it means we are going to pick one of the bases. Amen? We are going to pick one of the bases. Then raise it, then subtract what? The powers. That is division law. Do you understand? Yes. Are you following? Yes. Okay. So it means this is equals to A raised to the powers of X minus what? 1. Do you understand? Yes. Are you following? Yes. It's okay. Okay. Then we will look at let us also look at power law 3. Power law, right? You know that this is power, two of us. So if we have A raised to power this X, then we now have another power again, Y. The power law implies that. Since this is power and this is power, right? Yes. You use this power to multiply each other. Is that clear? Yes. So this will now be equals to A raised to the power of X times Y. Then this is the same thing as what? A raised to the power of X and Y. Do you understand? Yes. Are you following? Yes. Drop it. It's okay. You can write it. Yeah, this is a government college, Kurmin-Mashi, Governor Road, Kaduna. Are you not copying? Huh? Yeah, not copying, right? Okay. Yeah. So that is that. So this is part 4. We'll be looking at zero law. Zero law. Zero law. Listen, if we have a raised to power 0, it means what? 1. So anything raised to power 0 is what? 1, right? So even if we have, let's just say, a raised to power 2, open bracket, raised to power 0. 1. It's going to give you what? 1. Why? Because if you use this to multiply this, it's going to give you 0, right? So this will be a raised to power 0, which is equals to what? 1, right? It's okay. Then, if we have 5, assuming we have a all over b raised to the power of minus 1. Listen, because we'll be making use of all these laws to solve any problem. Is that clear? Yes, sir. Are you following? Yes, sir. Okay. So, if we have this, if we have something of this one, we can rewrite this in this form. This is the same thing as this denominator will now come up. So if this denominator come up, it will now be b all over what? A. This r is supposed to be all in bracket raised to power of 1. But let me prove to you. Yeah, you may ask how and why. So let's look at it together. Amen? Yeah. Let us look at it together. As long as mathematics is concerned, we have a all in brackets b plus 1. We can still rewrite this idiot in this form. This is the same as 1 all over a all over what? B. Amen? Amen. Are you following? Yes. So it means this is the same thing as 1 all over a all over b will now be the same thing as 1 divided a all over what? B. Can you see now? Yes. Are you following? Yes. So as long as we have something of this form, in mathematics, you have to convert this division. Huh? Yes. Division into what? Multiplication. Please wake those that are sleeping. Pause them. You either stand up. Don't sleep in the class. Stand up. If you want to sleep, stand up. If you know sleep is disturbing you, you stand up. It's okay. So let's look at it together. So here, let's look at it together. Let's look at it together. Amen?
Amen.
Okay. So now, here, we now, one, you convert this to what? Multiplication, right?
Yes.
So if you convert this to multiplication, this B, this denominator will now come up, this numerator will now come down. You are going to have B all over A. So 1 times B is B all over what? Can you see it now? So you should take it. Then